Now, I want to concentrate from now on, because I'm a theoretical physicist, I'm more delighted with this end of the problem, as to what goes or how do you make the guesses. Now, it's strictly, as I said before, not of any importance where the guess comes from. It's only important that it should agree with experiment, and that it should be definite as definite as possible. What you say then is very simple. We've set up a machine, a great computing machine, which has a random wheel in it that makes a succession of guesses. And each time it guesses a hypothesis about how nature should work, computes immediately the consequences and makes a comparison to a list of experimental results that it has at the other end. In other words, guessing is a dumb man's job. Actually, it's quite the opposite, and I will try to explain why. The first problem is how to start. You see, I'll start with all the known principles, but the principles that are all known are inconsistent with each other. So something has to be removed. So we get a lot of letters from people. We're always getting letters from people who are insisting that we ought to make holes in our guesses as follows. You see, you make a hole to make room for a new guess. Somebody says to you, people always say space is continuous, but how do you know when you get to a small enough dimension that there really are enough points in between? It isn't just a lot of dots separated by little distances. Or they say, those quantum mechanical amplitudes that you told me about, they're so complicated and absurd. What makes you think those are right? Maybe they aren't right. I get a lot of letters with such content, but I must say that such remarks are perfectly obvious and are perfectly clear to anybody who's working on this problem, and it doesn't do any good to point this out. The problem is not what might be wrong, but what might be substituted precisely in place of it. If you say anything precise, for example, in the case of a continuous space, suppose the precise proposition is that space really consists of a series of dots only, and the space between them doesn't mean anything, and the dots are in a cubic array. Then we can prove that immediately is wrong. That doesn't work. You see, the problem is not to change or to say something might be wrong, but to replace it by something, and that is not so easy. As soon as any real, definite idea is substituted, it becomes almost immediately apparent that it doesn't work. Secondly, there's an infinite number of possibilities of these simple types. It's something like this. You're sitting working very hard. You've worked for a long time trying to open a safe. And some Joe comes along who doesn't know anything about what you're doing or anything except that you're trying to open a safe. He says, why don't you try the combination 10, 20, 30? Because you're busy. You're trying a lot of things. Maybe you already tried 10, 20, 30. Maybe you know that the middle number is already 32 and not 20. Maybe you know that, as a matter of fact, this is a 5-digit combination. There we have. So these letters don't do any good, and so please don't send me any letters trying to tell me how the thing is going to work. I read them to make sure that I haven't already thought of that. But it takes too long to answer them because they usually in the class try 10, 20, 30.